This video covers everything we did today on Monday, December 13th in 8th grade honors math. The first thing I'd like you to do is pause this video, open up ClassKick, and complete slide 1. Pause the video, open up ClassKick, and complete slide 1. On slide 1, you had to decide which line doesn't belong. There were a few main things we talked about. A lot of people noticed that line S and T both had a slope of 1/3. Of course, line U does not have a slope of 1/3. But one other thing we noticed is that line U, much like S and T, is also moving in a similar direction. Just like the graphs that we've seen in the past, it is moving what kind of looks like upward towards that upper right-hand corner of our paper. We can see that we have a bunch of lines that intersect right here, and line V moves in another direction. And that's what we're going to be talking about today, is how to deal with these lines that move in other directions. And we'll get some more specific vocabulary around that in just a second here. If you had another reason that a line didn't belong, that's great too. Just make sure you notice why V is different, which is that it's moving in a different direction from the other three. Today's learning target is I can use a graph to determine whether a slope is positive or negative and justify my reasoning. We'll also work on calculating those positive and negative slopes. Please join me on slide 3. Slide 3 says, Noah put $40 in his fare card. Every time he rides public transportation, $2.50 is subtracted from the amount available on his card. I'm going to highlight key information here. This is like a SEPTA card, where if you put $40 on the card, each time you ride it, you'll spend $2.50 of those dollars. So after 0 rides, we know that he would still have $40 left. But after 1 ride, he's used $2.50, and so instead of having $40 left, he has $37.50 left. After 2 rides, we know that he would have $35 left. And after X rides, he would have $40 minus however many times he's ridden times $2.50, which we can write as $2.50x. What this $2.50x means is simply that if we multiply the number of times he's ridden SEPTA, x, by $2.50 per ride, we see how much money he has left over. Go ahead and pause this video to graph the relationship between the amount of money on his cards and the number of rides. What I mean by that is all of the coordinate pairs that would represent rides and money. For example, in B, you would have a coordinate pair of 1 ride, $37.50 left. So here are some of the points that you should have in your graph. We know that when Noah has taken 0 rides, he has $40 left. When he's taken 1 ride, he has $37.50. 2 rides is $35. And then each time he takes a ride, $2.50 simply gets subtracted from his card. And so we can just follow the graph down in this kind of pattern, and we can be confident that we're plotting the correct coordinate pairs because the y-axis is scaled by 2.50s and the x-axis is scaled by 1. So each time he takes another ride, his card has $2.50 less dollars on it, and we can draw a line through those points. Now, 3 says, how many rides can Noah take before his card runs out of money? Where do you see this number of rides in your graph? So the question is, at what point will Noah no longer have any money on his card? Go ahead and pause this video and answer question 3. The answer to question 3 is 16 rides. And we can see that 16 rides is the x-intercept on our graph. It's located right here at 16. And it definitely would be easier to type this. I'm just going to write 16 rides. It is the x-intercept, which is where y equals 0. And that makes sense, right? Because if y equals 0, then we know that the number of dollars left on the card is 0. Y is cost and or dollars on card, and if y is 0, then there's no more dollars left on the card. Now, after we completed this graph, we discussed in class the slope of this line. If you were to draw a slope triangle to calculate the slope of this line anywhere on the graph, let's say we move from 20 to 15 and 8 to 10, we would have 5 over 2. And so the slope of this line is 5 over 2, which in this context, since we're talking about money, it makes sense to convert that to a decimal. But it's not a positive 5 over 2. It is a negative 5 over 2. It's negative $2.50. And this makes a whole lot of sense if you think about what's happening here. Because for every ride, so $2.50 per ride, Noah loses $2.50. And that's why the $2.50 is negative, because he's losing that money. And when we have lines that are moving in this direction, they typically have a negative slope. So if we go back to slide 1 with the warm-up, we can see line V also has a slope of 1/3, right? The rise is 1 and the run is 3, but it is a negative 1/3 because we are moving over left before we move up 1. And we have a negative slope. Join me on slide 4. Here's a graph that shows the amount on Hans' fare card every day of last July. Go ahead and pause this video and answer questions 1 through 4. Pause the video to answer 1 through 4. So you might have noticed that in July, the fare is not changing. So he is not using the card. And we know that because no matter how many days have passed, the amount of dollars on his card is just 20, right? And so you could label any point on the graph. Like for example, this is 4,20, and make sure that you labeled 3 points because that's what they asked you to do in question 2. So if you need to label more, you can pause. It says write an equation that represents the amount on the card in July, Y after X days. In this situation, Y is always equal to 20. No matter what X is, Y is equal to 20. And so we don't even need an X in our equation. And the reason is because no matter what X is, Y is the same. And so in this case, the slope of the line is 0. And the reason is because he used $0 per day. And so that's the other key takeaway from today, which is that when you see a line that is flat, it has a slope of 0. When you see a line that moves in the negative direction, like this line, it has a negative slope. Join me on slide 5. Your job is to complete the rest of Classkick independently. Once you have finished that, make sure you pay close attention to the exit ticket on slide 7. And then you do have homework posted in Schoology. It's going to be a Delta math assignment tonight. If you have any questions about those directions or you need help on 9.4, the homework, or the exit ticket, please make sure that you're sending me an email.